All right, here we go. This is our third example here. I've got a rational function here. A rational function is just when there's a function on top of the fraction, a function in the denominator of the fraction. We can gain a lot of information from doing some basic stuff here. I've got a grid here. We're going to graph it as we go. There's four different things that we want to look like. Let's get going. All right. I like to look at the intercepts, so let's look at the x-intercepts first. Okay, so the x-intercepts are always when is equal to 0. And for this function to be equal to 0, it's a fraction. The only way a fraction is equal to 0 is if the top, the numerator. So I'm going to set this guy equal to 0. And, ooh, it's factorable. All right. X minus 2x plus 1. And then I get two x-intercepts. I get two x-intercepts there. So we're going to graph this as we go. So let's just plot at it's not very, but negative 1 and 2. Let me do that again. Negative 1 and 2. There we go. Okay. That's another one. Let's look at the y-intercept. Okay, there. Let's see here. So the y-intercept. So the y-intercept always has an x-coordinate of 0. Always has an x-coordinate of 0. So what I'm going to do is I'm going to take the function, I'm going to plug in 0. And really, when I 0, all of these x terms go away. I'm left with negative 2 or negative 8 or 1/4. 1/4, there's the y-intercept. Really, these last terms here, the top and the bottom, I just divide those. So 1/4, I'm just going to guess. It's right above 0. You know, whatever. All right, two more things. Two more things here. Let's see here. Asymptotes now. All right, I'll go and look at some asymptotes. Let's start with what's easier, I guess. Vertical asymptotes, we're more used to. So a vertical asymptote is where the function's not defined, where it doesn't. It's a fraction. The only times fractions don't work is when the bottom of the fraction is equal to 0. So I got to find out the bottom of the fraction is equal to 0. Alright, this one turns out to be factorable as well. Makes it nice and easy for us. So we have a vertical asymptote at positive 4, negative 2. Alright, so I'm going to sketch these in. I'm going to use so what did I say? Positive 4, negative 2. So there's an asymptote, and positive 4, so there's an asymptote. Alright. Last thing will be our horizontal asymptotes. Okay, our horizontal asymptotes. So, when we're looking at our horizontal asymptotes, that's when we compare the degree of the top and the bottom. So in this case, we said m and n. So in this case, they're the same, all right? They both have degree 2. They both have degree 2, they're the same. So our horizontal the y equals equation is going to be the ratio of the coefficients. It's 1 over 1, which is obviously just 1. So we have asymptote at 1. What I'm going to do here is, because I do have two vertical asymptotes, let's see here. I'm going to extend these on the edges. Okay. There's a chance that it can cross a horizontal asymptote on the inside. It's more of what we call it an end behavior asymptote, more accurately. All right. So we can actually graph what we have so far. We can graph what we have just from the information here. We have enough. All right. It doesn't matter. Let's see. It's green. Okay. All right. Here's what I see. All right. Using these intercepts here, I see the shape of a curve kind of taking shape here. And it has to approach the asymptotes. Okay? So if it curves through those intercepts like that, it has to continue to curve down and approach the asymptotes. Can I try that again? That's terrible. Alright. My smart board is not calibrated very well right there. Alright, let's try this. Cruising up here, it's going to go through those guys. Cruise down there. I never said I could draw though. Okay. If it approaches this asymptote, I'm looking at this one right here. If it approaches it on the left, up here it has to approach on the right. And then also it has to approach going up on the left side here too. And there's our graph. It's ugly. If you step back, that's bad. Sorry people, that's bad. But that's good. A few more things before I stop here. Let's talk about all right. Just taking the domain and the range from the graph. We don't want to do. Let's copy. Let's go down a little further. And I want another copy of this. Actually, no, undo. Let's do it on this. There we go. All right. Let's talk about the domain and the range here. Domain and range. Okay. So the domain is on the x-axis. Where is it defined? It's defined all the way on the left, and it comes up here. It's not defined at that first. So the domain starts at negative infinity, goes up to -2. Union. It's defined in between -2 and 4, and also defined all the way to the right of 4. All right, that's the domain. It's on the x-axis. Everywhere except asymptotes. The range is defined everywhere except that, what do you call that thing? That horizontal asymptote. Actually, this is more complicated. Let's not do that. I only care about the domain here. All right. That's pretty good. That's pretty good.